What's up, ninjas? Brendan here. Welcome back to 7 Days of Injective, and today we'll be covering the exchange module. For day 6, we will be using a spot market exchange on Injective, and we will not be using an automated market maker formula, which is often the only option on other blockchains, right? So we're not using one of these. We're going to be instead using an order book, which is what in real life exchanges, such as stock exchanges, actually use. So first we'll learn about what each of those are and why other blockchains use AMMs and why Injective uses an order book. Then we'll learn about Injective's offering, the central limit order book. And then we'll get back to the repo that we've already got set up and continue using it. Then we'll learn about the exchange precompile. So we've covered the bank precompile previously with the multi-VM token standard. Now it's a different precompile. And then finally, we will interact with the spot market on Injective. All right, let's talk about automated market makers versus on-chain order books, and starting with the first one, AMMs. So AMMs are a trading mechanism that replaces direct counterparties with a deterministic pricing function. So liquidity is supplied into shared pools by liquidity providers rather than by the limit orders, the orders that are placed inside. So trades execute against the pool according to a mathematical formula called an invariant that governs the price curve. And the most common invariant is the constant product formula, where the product of two asset reserves remain constant. And so prices are derived from the ratios of those two against each other within the same pool. So every time there's a trade, the ratio changes, and so therefore the prices change as well. So it moves along a price curve. Now, liquidity providers, they earn fees proportional to their share of the pool and the total trading volume. So AMMs provide continuous liquidity, permissionless access, and deterministic execution. And they are, however, limited because they have capital inefficiency and increased slippage during large trades, as well as impermanent loss when there is a price divergence from external markets. Now let's talk about the other alternative, which is order book based exchanges. So order books, they structure liquidity from the sum of the buy and sell orders that is at specific price levels. So traders submit their limit orders that are entered into the order book, or market orders that consume existing liquidity. So limit orders and market orders. Matching occurs when the bid price and the ask price, they touch each other or they cross each other. And so there is a strict price and time priority when that happens. Order books enable accurate price discovery and dense liquidity at competitive price levels. And they also have strong capital efficiency, since capital is committed at specific prices. They support advanced trading strategies, including professional market making, arbitrage, and low latency execution. However, it does have challenges as well because the systems are more complex, there is more fragmented liquidity, and they're also historically incompatible with on-chain execution, i.e. on blockchains, because blockchains have latency constraints. They have transaction fees in terms of gas, as well as it creating a lot of data on chain. In other words, the state that needs to be stored on chain is higher. All right, so let's talk about Injective's offering. So Injective implements a fully on-chain order book through its native exchange module, and that's integrated at the protocol level rather than deployed as a smart contract. So order matching is embedded directly in the blockchain stack. So that means you can get deterministic execution and high throughput because you don't actually have to go through a smart contract in order for that to happen. The exchange module, it maintains spot prices and derivatives in order books with price time priority enforced at the consensus layer. Orders can be placed, matched, partially filled, or even cancelled within the same block. Matching logic is executed by validators, ensuring fairness and preventing minor extractable manipulation, right, such as MEV. Injective employs something called FBA, or frequent batch auction, in its model. So it matches batches at a time. All orders are submitted within a block. They are collected and they're sorted and they're matched automatically. And this design, it mitigates front running, which is one of the main ways in which MEV attack vectors happen. So this improves execution integrity, and it aligns the trade finality and block finality together. For derivatives, you have or margin checks or funding payments or liquidations and risk controls, etc. Right? These are integrated directly into the exchange module as well. So this allows Injective to support perpetuals and futures markets for those with native risk management while being fully on-chain. By moving the order book and matching engine into the core protocol, Injective achieves the precision and capital efficiency of traditional exchanges while preserving decentralization, composability, and the guarantees of immutability and cryptographic certainty that are inherent from blockchains. So the next thing we're going to do is we're going to switch to the repo and see all of that in action, right? This repo will demonstrate how to interact with the Injective Exchange module using the Injective TypeScript SDK. So we need to CD into day 6, right? But I see that I'm already in it, so I will do that. And then within that, there is a spot market directory. And all you need to do is CD into the spot market directory. And within this, run npm install. And that should take a while. The other thing we need to do is to make sure that we get .env.sample to .env. And I'm going to open that. Right. So here we need a wallet private key and an Injective address. And we need to insert that. So I am going to get my address from here. Address. And I'm going to get my private key from here, from MetaMask. So actually, I think I have that saved over here. All right. So this is account 1. That's 0xCAC. Yep, that's the one. And then I will copy the private key from that. All right, so now I'm going to fetch some market data. And in order to do that, I am going to run this script. So I'm going to run npx tsx that allows us to run a TypeScript file directly. And this is the fetch file. We'll take a look at it before we actually run it. Right, so we're importing the Injective Labs SDK over here. And what this does is it calls the fetch balances function within the SDK's API, and then it'll output the results. All right. So let's go ahead and run that. All right, let's just make this bigger so that we can see it in full. So we can see here that we've got a market for INJ and USDT, and another one for Ape USDT, INJ and Ape, and so on and so forth, right? So we've got multiple markets for multiple spot markets, and it's going to say the top result, the top line over here says minimum notional of this market is this much. Now we'll get to what that means in a little bit, what the meaning of a notional is. So each one has a market ID. So this is a unique identifier. It also has a ticker, which is, you know, what you see in the stock market. It's basically the two symbols that are being traded against each other. And we also have base decimals and quote decimals. So these are essentially showing our precision, that we're showing the number of decimal places that we see. Then we also say min price tick size as well as min quantity size. And these are precision adjustments for chain formatting. So they're essential for converting human readable prices to chain compatible formats. All right. And just want to highlight again that this indexes spot API dot fetch market. This is the part that is doing the heavy lifting. Like that's the part that gets a specific market. Now, the output over here that says the minimum notional of the market, right? It's basically price times quantity to meet the minimum requirement. So in order to do a trade, your trade has to be the price times the quantity that you're trading needs to be at least this much. Otherwise, you can basically clog up all the exchange with many tiny transactions. And so to disable that, we have the concept of a notion. The next thing is the spot limit orders, right? So we're going to create the limit order message. Inside the SRC folder, the source folder, press the limit order button. And inside there, we can see make message create spot limit order. So it constructs the order like so. And basically this handles all of the functions that are required to create the order, right? And then let's construct the actual limit order. So to do that, we'll open the place order and we'll run this command. So in place order, let's open that up first. So this file over here, right? What it does is it does the conversions and then it calls the make message create spot limit order that we looked at earlier on. That's a utility function. Then it inserts all the other details that are necessary. And then it broadcasts the message to the network. And then it gets the transaction hash as a result. So let's run that. All right, let's expand the output. We have failed to meet the notional amount. So let's change the amount. Let's change the amount to say 0.3 and then run that again. All right, there we go. So we see the output, and within the output, we can see the transaction hash. And so transaction returns the transaction hash. And what I'm going to do is open up the Injective Explorer. Right, so that's at testnet.explorer.injective.network. And let's take a look at this transaction. So we can see that it has succeeded. The status is successful. And we also have the transaction hash, obviously. And we have the block where it happened and the amount of gas it's used and the messages. So this essentially shows the details of the order that was made. So once you place the order, we can query its status to see if it's been matched or it's still on the order book. And so I will take a look at src/status and we'll replace your INJ address with our actual INJ address, which is this one over here. Actually, in the faucet, we'll see it, this one. All right. And then we can run npx tsx src/status.ts. All right, so we can see active orders, none, recent trades, this, right? And the trade is this much. So there we go. So it looks like the trade has already occurred. So what active orders displays is any orders that are currently open in the order book for my account. And it shows all of these details. The main ones you want to look for are the price and so on. That's active orders. And with recent trades, it's the same thing, right? So we want to look for price and quantity. Those are the two main ones. And then, of course, there is also a fee, the amount that was paid in order to make the trade. So we can see that the order that we placed was already matched and the trade has occurred. So sometimes the order will be filled immediately because there was another bid that matched, but then sometimes there aren't either. We just did a sell. I'm going to do a buy next. So in place order, right, the order type is 1 for buy and 2 for sell. So now I'm going to change this to 2 and it'll sell instead. And then I'm going to do that, right? So rerun the script. So npx tsx src/placeorder.ts. Run that again. All right, there we go. So we got a transaction hash. And now I'm going to repeat the status command. All right, and we can see here that we do indeed have an active order over here. So that's the order that we just placed, and it hasn't completed yet. We can take a look at the transaction hash. This one over here. Go back to the Explorer and search for this one. All right, so this is again the order details. So this is a limit sell order. Now take a look at the previous one. This was a limit buy order. So I try to buy 0.3 INJ for 5.4 USDT. And now the most recent one was I'm going to sell 0.3 INJ for 5.5 USDT. Maybe someone else needs to come into the market and put their order on. All right. One more thing I'd like to highlight is the get market price function in src/limit order. So this function over here, it uses index.spot API fetch order book v2 and passes in the market ID, and that is how it gets the prices, right? And this function is actually used for determining what the actual order price to use is, and calculating slippage if there's any, and also to monitor the market as well, generally. Now, the other thing I'd like to highlight as well is to look at the convert chain price to price function. Right? So what this does is it takes data that is from on the blockchain, and it comes in that format that blockchains use, and we're just converting it back to a human readable format. And so this function is another utility function that assists with that. So we fetched market data, we've placed an order, a sell order, we've also placed a buy order, and we've also obtained the market price, and we've also seen how to get that market price to be human readable. Congratulations, because we just covered the theory and demos for day 6. If you haven't gone through the steps yourself yet, please be sure to do so now. They'll only take a few minutes to complete. And once again, you have the options to re-watch this video from the beginning or follow the text instructions in the linked tutorial below. In the next video, we'll have a short quiz with a few multiple choice questions. So watch that to assess your own understanding of this topic. Thanks for watching, and see you in the next video. But before you go, note that this is a preview edition of the video that is part of the 7 Days of Injective course. We're creating the full version of this course with all the bells and whistles, and if you watch this far, I'm sure that will be keen on that too. So do sign up using the form by using the QR code or clicking on the link in the description of this video. For now, on to the next video.